So not to sound like a broken record, but we're asked to factor completely a binomial in this case, a polynomial expression. Our first step always is look for the greatest common factor. So is there a greatest common factor? First we look at the coefficients. What's the greatest common factor of 4 and 64? It's going to be 4. And then what about a to the 5th and a? That's going to be a. And then b and b, that's obviously going to be b. So 4ab times a to the 4th minus 4 times what is 64? 4 times 16 is 64. And then we already factored out the a and b. So we have a binomial left. It's subtraction. And since the leading term, the variable a, is being taken to the 4th power, that makes me question, is it a difference of squares? And the reason why I say that is because if it was odd, I'd wonder, is it a difference of cubes? It's even, the exponent that is even. So I'm wondering, is it a difference of squares? And it is, because this ends up equaling 4ab times, well, this is just a squared minus, and 16 is 4 squared. So remember, with a difference, and this is going to get a little confusing because we're using a and b in our expression. So just remember, this is just the general form of a squared minus b squared equals a minus b times a plus b. We're talking about different a's and b's here, though. So now we just need to recognize that this is 4ab. Our a in our formula is actually a squared now. So this is just going to be a squared minus, our b is 4, times a squared plus 4. But now we have another difference of squares with a squared minus 4. So this is going to be 4ab times, well, this is a difference of squares, a squared and 2 squared. So that's just going to be a minus 2 times a plus 2. And again, that's still multiplied by a squared plus 4. And we can't factor any further. Again, we have a sum of squares, but unless we are explicitly asked or told to factor the sum of squares, we just leave it at that. And then to multiply, again, sum of squares is considered prime unless you're specifically told to factor it, and then we have to use the complex number system. So we're just going to leave it as it is and check by multiplying through to verify that we get what we originally started with. So let's look at, first, a minus 2 times a plus 2. So we have 4ab times a is a squared plus 2a minus 2a. So the middle terms cancel, and then we're left with minus 4. And that's times a squared plus 4. Now we'll multiply those together using FOIL. So that equals 4ab times a squared is a to the 4th. A squared times 4 is 4a squared. But then we're subtracting minus 4a squared from the two inside terms. So those cancel, and then minus 4 times 4 is minus 16. And then if I multiply back in, distribute the 4ab, I end up with 4a to the 5th b minus 16 times 4 is 64ab. And that's what we originally started with, so our solution checks. And this is the factored form of the original polynomial we were given.